Let's do these 6 indefinite integrals. So the first one is the integral of x plus 6 divided by the square root of x dx. So first of all, let's break this down into two fractions. So x divided by square root of x is x to the 1/2 plus 6 divided by x to 1/2. I didn't apply any rules. This is just how we break down the fraction. And then we have x to the first on top, x to the 1/2 on the bottom. So that will be the power on top, subtract the power on the bottom. So that will be the first power minus 1/2 power. So that is equals to 1/2. And then 6 divided by x to the 1/2 is x raised to x to the negative 1/2 dx. And then you apply the simple power rule. So 1/2 plus 1, and then 1 divided by that. And then this one, negative 1/2 plus 1, 6 divided by that. Okay, and then that is equals to 1 over 3 over 2, right? So that will be 2 over 3, x to the 3/2. And then that one, negative 1/2 plus 1, so that will be 1/2, 6 divided by 1/2, which is 6 plus times 2. That is equals to 12, and then this is x equals to 1/2, and then plus c, right? So I accept rational exponent, but if you are doing homework online and they would like you to put this back to radical, then you have to do 2 over 3, the square root of x to the third, plus 12 square root of x plus c, depending on the preference. Okay, next one, we have the integral of x plus 1 times 3x minus 2 dx. So this one we have to open up the two factors. So we have x times 3x, so that is equals to 3x squared, and then minus 2x plus 3x, negative 2 plus 3 is equals to x, and then 1 times negative 2 is equals to negative 2. And then apply simple power rule. So you have x2 plus 1, 3 divided by 2 plus 1, and then 1 plus 1, 1 divided by that, minus 2x plus c. If you can do these steps on top of your head, then you do not need to show this step. So you have, at the end of the day, you have x to the third plus 1/2 x squared minus 2x plus c. So that is your answer. And then the next one, we have some trig functions going on right here. We have the integral of 5 cosine x plus 4 sine of x dx. What is the integral of cosine? So we know the derivative of sine is cosine, so the integral of cosine is sine. So that will be 5 times sine of x. What about the integral of sine? The integral of sine is negative cosine, so we have negative cosine x. The 4, don't touch the 4, plus c. So you have 5 sine x minus 4 cosine x plus c. So that is the general solution. And then moving on to the next one, we have a cosecant times cotangent. So the integral of cosecant x times cotangent x minus 2x dx. Do you still remember that the derivative of cosecant x is equals to cosecant times cotangent? So, but the derivative, okay, just write this out. The derivative of cosecant x is equals to negative cosecant x times cotangent x, but there is no negative here. The minus belongs to the 2. Alright, so this one we have to add a negative in front of the cosecant, and then the integral of 2x is just x squared, right? So if you take the derivative of x squared, you can easily get the 2x and then plus c. So that is the answer. And the next one, we switch to another color. We have the integral of secant square theta minus sine of theta d theta. The derivative of tangent, d theta, right? Because the independent variable is theta of tangent is equals to secant. All right. So this one, that gives me a tangent theta, and then we also have sine, so that is the derivative of cosine. The derivative of cosine is equals to negative sine. So since we already have the negative, then this will be a plus cosine theta. And don't forget to add the plus c. The plus c is not optional, right? You have to add a constant to it. Why do you need to add the constant to it? Because when you take the derivative of the answer, the derivative of constant is equals to 0. I know that equals to 0, that means the constant means nothing. But when you do indefinite integral, you must add the constant. Let's go to our very last problem. So we have the integral of tangent square y plus 1 dy. So this one we do not have the integral of tangent square, so therefore we have to use the fundamental identity. So fundamental identity, so that is tangent square plus 1, that is equals to secant square, right? So that gives you the integral of secant square y dy, and then you have to know that the integral of tangent is equals to secant square. So the integral of secant, so you undo the derivative, then you get the tangent back. So tangent y plus c. So this is the general solution. Again, everything we did right here, they are called the general solution, because we don't know what the plus c is. All right, so in the next video, I will show you how to do particular solution. So if you think my instruction is helpful, let me know in the comment below. Like the video for me, subscribe to my channel. Appreciate your help and support. See you all in the next one. Signing off for now.